Welcome back to the deep dive. I was sitting there this morning, coffee in hand, staring at my phone, and I was trying to log into this new game my nephew has been nagging me to play.
Oh, yeah.
And it was the usual dance. I had to create a new account, again, had to verify my email, again.
Yeah.
Then I realized I had to connect a specific wallet, but surprise, surprise, this game lives on a different blockchain than the one where I, keep my fund money.
So now you're looking at bridging funds, paying gas fees, waiting for all the confirmations.
Exactly. It's the death by 1,000 logins, and I put the phone down. It just wasn't worth the friction. And it
Okay.
hit me. For all the talk about the global village and this connected world, the internet we actually use is incredibly fragmented. It's just a bunch of disconnected
We
islands.
call those walled gardens. And honestly, most of us have just accepted it as the status quo. We think, well, my bank account is over here, my Steam library is over there, my Twitter identity is over here, and never the twain shall meet.
Right. If I buy a digital sword in a game on my PlayStation, that sword lives and dies on Sony servers. I can't take it to my PC.
Nope.
I can't sell it for rent money on some generic marketplace. It's not really my sword.
It's a database entry.
Yeah, it's a database entry that I'm renting.
That is the fundamental problem. But today's deep dive is about a stack of research, and this is part 3 of our series on the Oasis ecosystem, that says, no, it doesn't have to be this way.
We are looking at a stack of documents today that is, frankly, a little intimidating. We've got these technical white papers on the new base Solana bridge architecture. We've got the internal documentation for something called OpenServe AI, and we have the developer logs for the Star Omniverse development kit.
It's a heavy sack. It really is. But when you zoom out, these aren't 3 separate topics. They are 3 pieces of a puzzle that, when you snap them together, create something the authors are calling a digital singularity.
Now, usually when we hear singularity, we think Terminator, We think Skynet becoming self-aware.
Right. The moment AI becomes smarter than humans and we all, become batteries in a pod somewhere.
Exactly.
This isn't that. This is a digital singularity. It's the moment where the walls between your apps, your finances, and your identity just dissolve.
So the mission for this deep dive is to figure out how we get from my frustrating morning of 50 logins to this everything economy. And fair warning to you, we are going to get into the weeds today. We aren't just skimming the surface.
Not at all.
We are going to talk about byte limits on the Solana blockchain. We're going to talk about Merkle mountain ranges, and we're going to talk about AI agents that might just have a better credit score than you do.
It's going to be a wild ride. But we have to start with the plumbing. Because none of this sci-fi stuff, the AI agents, the metaverse items jumping between games, none of it matters if the pipes don't work.
And the pipes in this case are the connections between blockchains. Specifically, the source material focuses heavily on a new bridge between Base and Solana.
This is a critical piece of infrastructure to set the stage. Base is Coinbase's layer 2 network. It's built on Ethereum. It's secure. It's, corporate friendly. It's where the serious money often sits.
And then you have Solana.
Right. Solana is the race car.
Yeah.
It's high speed, high throughput, massive transaction volume.
Yeah.
Historically, getting these 2 ecosystems to talk to each other has been a nightmare.
Usually you have to use a third-party bridge. And if you follow crypto news, you know that third-party bridge is basically a synonym for thing that gets hacked.
Exactly. Bridges are the weak points. They are the honeypots.
Well,
But the engineering blog post we're reviewing today details a solution that solves this at the protocol level. It's a native integration.
okay.
But what really stood out to me was that this bridge is asymmetric.
Asymmetric, that's an interesting word for a bridge. Usually a bridge is just a road. It goes both ways.
It does go both ways,
Yeah.
but the mechanism for travel is completely different depending on which direction you're going. And that is because Base and Solana are they're fundamentally different beasts with different constraints.
Okay, so let's walk through the deposit flow first. I'm on Solana. I want to move money or data to Base. What is actually happening under the hood?
So you start on Solana, you want to lock up your funds or send a message, but immediately the engineers hit a brick wall.
What's the wall?
It's a size limit. Solana is optimized for speed. We're talking 400 millisecond block times. To keep that speed, the network imposes a very, very strict limit on how much data can fit in a single transaction.
And that limit is?
1,232 bytes.
1,232 bytes. That is microscopic.
It's tiny. For context, a standard tweet is 280 characters, which is roughly 280 bytes, depending on your encoding. So Solana transaction can hold maybe 4 tweets worth of data.
And that includes all the metadata, the signatures, the headers,
Yeah.
all of it.
All of it. So if you are trying to send a complex instruction to the Ethereum virtual machine on base, saying, take these tokens, deposit them in this specific liquidity pool, and mint a receipt, that instruction simply does not fit in the suitcase.
So if the suitcase is too small, you can't travel. End of story.
In a normal system, yes. But the solution they implemented is really clever. They build a buffering system.
Okay.
Think of it like trying to move a large sectional sofa through a tiny apartment door. You can't just shove the whole sofa through at once.
You should dismantle it, take it apart.
Precisely. You take the cushions off.
Yeah.
You unscrew the legs.
Yeah.
You separate the sections. The bridge software automatically breaks that large Ethereum message, that call data, into chunks. It sends chunk A to a temporary buffer account on Solana, then chunk B, then chunk C.
So they are reassembling the sofa in the hallway on the Solana side before they try to send it over.
That's a great way to put it. Correct. They load the data into a program-derived address, a PDA vault. Once the bridge program sees that all the pieces are there, it stitches them back together and says, okay, the message is complete. Now we can initiate the bridge.
That sounds like a lot of steps. Does that make it slow?
Surprisingly, not really. Because Solana is so fast, firing off 3 or 4 of those chunk transactions takes milliseconds. To the user, it feels instant. But there is a security catch here that we absolutely need to mention.
The supermajority.
Right. Speed is great, but security is better. The bridge doesn't just trust the first validator who says, yeah, I saw the money. It waits for a supermajority confirmation.
Which is what percentage? Is there a hard number?
It's 66% plus. In a proof-of-stake system, if more than 2/3 of the validators sign off on a block, it is mathematically, effectively impossible to revert that transaction without destroying the value of the entire network.
So going from Solana to Base is fast. We dismantle the sofa, shove it through the door, reassemble it, wait for 66% of the room to nod their heads, and we're good. Roughly 15 seconds.
Roughly 15 seconds, yeah. Now, let's try to go back.
The withdrawal flow. Base to Solana.
This is where the asymmetry really kicks in, because now we have the opposite problem. We are on Base, which is Ethereum-based. We have plenty of space for data, but we need to prove to Solana, that tiny restrictive network, that a transaction actually happened.
Ah, we have to fit the proof inside the tiny suitcase.
Exactly. Imagine Base has processed 1 billion transactions. You need to prove that one specific withdrawal you made is valid. Usually a proof like that gets very heavy, data-wise. If that proof is larger than 12,232 bytes, you are stuck.
You literally can't get your money out.
You literally cannot withdraw your money.
So how do they compress 1 billion transactions into a proof that small? That sounds impossible.
They use a data structure called a Merkle Mountain Range, or MMR.
A Merkle Mountain Range. That sounds scenic. I'm guessing it's not a vacation spot.
It is deeply mathematical, for sure. Most people know a Merkle tree. It's how Bitcoin works, right?
Right.
You hash data together, and you get a single root hash. And MMR is a variation of that. Picture a range of mountain peaks.
Oh, okay, I'm visualizing it.
As you add more data, more rocks to the bottom of the mountain, the peaks shift slightly, but the overall structure remains very, very stable. The beauty of the NMR is that it allows for what they call compact inclusion proofs. Meaning that even if the mountain grows to be the size of Everest's billions of transactions, the map you need to prove that a specific rock exists at the bottom remains tiny.
Wow.
It scales logarithmically.
So the proof never gets too big for the suitcase.
Exactly. It ensures that no matter how popular Base becomes, no matter how much data is on there, you can always bridge back to Solana.
But there's a time penalty here, right? We talked about 15 seconds for the deposit. This sounds like it takes longer.
Yes. And this is the trade-off of the optimistic roll-up architecture of Base. When you withdraw, you are waiting for Ethereum Layer 1 finality.
We are waiting for the big boss to sign off.
We are waiting for the sequencer batch to be posted and finalized on Ethereum Made It.
Yeah.
And that takes about 15 minutes.
So 15 seconds one way, 15 minutes the other.
That's the asymmetry. But it works. And it provides the rails. We have secure protocol-level highway between the high-speed execution layer, Solana, and the deep liquidity layer, Base.
Okay, so we have the highway, the plumbing is installed. Now we need to talk about the traffic. Who is driving on this highway?
This brings us to section 2. And this is where we shift from, let's be honest, kind of boring infrastructure to something that feels very, very cutting edge. In this new ecosystem, the primary users might not be humans. They might be autonomous AI agents.
We're entering the agentic economy.
We are. The source material here is the OpenServe white paper and its documentation. They describe OpenServe not as an app, but as an orchestration layer.
Or nervous system for AI. I like that phrase.
Which is a great metaphor. Because right now, what do we have? We have LLMs, we have ChatGPT, Claude, Llama. These are amazing, but they are essentially brains in a jar.
That's a vivid image.
It's true, though. ChatGPT can write you a poem. It can write code for you. But can it go out and, I don't know, buy you a pizza?
No.
Can it negotiate a contract with another AI? Can it manage a crypto wallet without you holding its hand every step of the way?
Not really. It can output text, but it can't take action. It can't do things.
There's the action gap.
Yeah.
An open source is designed to close it. But they are also solving another problem they call framework fragmentation.
Which is just a fancy way of saying developers can't agree on a coding language.
Pretty much. One developer built an agent in Python, another builds one in Rust, another one's in TypeScript. These agents live in different runtimes. They can't talk to each other.
So OpenServe acts as a framework of frameworks.
Yes, exactly. It allows a Python agent to collaborate with a Rust agent to execute a complex task together.
But there's a bigger elephant in the room when we talk about AI agents handling money or important tasks. And that is, they lie.
Hallucinations.
Right. I mean, I love ChatGPT, but sometimes it just makes things up with total confidence. If I hire an AI agent to manage my portfolio, I cannot afford for it to hallucinate a trade.
Oops, I bought $1 million of a coin that doesn't exist because, I like the name.
Exactly. How does OpenServe prevent that from happening?
They use a framework called B.R.A.I.D.
B.R.A.I.D.
Bounded Reasoning for Autonomous Inference and Decisions.
Okay, let's unpack that. How is B.R.A.I.D. different from how an LLM usually thinks?
Usually we use something called chain of thought reasoning. You ask the AI a question, and it just sort of talks to itself. First, it should do this, then maybe that, oh, that reminds me of this other thing. It wanders.
Right.
It's like letting a toddler tell a story. Ideally, it makes sense, but sometimes they end up on the moon.
So chain of thought is open-ended. It can go anywhere.
Yes. B.R.A.I.D. clamps that down. It implements a two-stage protocol. Think of it like a construction site. You have the architect and you have the builder.
Okay, I'm with you.
Stage one is the generator. That's the architect. This is a high-capacity, really smart model like GPT-4. Its only job is to create a blueprint. Specifically, it creates a logic diagram, what they call a mermaid diagram.
So it draws a flow chart. Step 1, check balance. Step 2, if balance is greater than 100, buy, else stop. That kind of thing.
Exactly that. It maps the logic visually and strictly. Then we move to stage 2, the solver, the builder. This is a much smaller, cheaper, faster model. It takes that blueprint and simply executes the steps.
It doesn't think.
It doesn't improvise. It just follows the lines on the flowchart.
Yeah.
Because it is bounded by that diagram, it can't hallucinate a new step. It can't wander off.
That is brilliant. So you separate the planning from the doing.
And the economics of this are staggering. The white paper claims this method is up to 122 times more cost-effective than just using raw GPT-4 calls for everything.
122 times.
Yes. Because the solver model can be very small and cheap. It doesn't need to be a genius. It just needs to follow instructions perfectly.
So we have cheaper agents, and we have more reliable agents.
Yeah.
But there was another term in the OpenServe docs that sounded a bit spy novel-ish. Shadow agents.
Shadow agents.
Are these secret agents working for the government? What are we talking about here?
No, nothing that sinister, although the name is very evocative. Shadow agents are efficiency mechanisms. Think of them as the invisible staff in a high-end hotel.
Okay.
When you stay at a hotel, you interact with the concierge.
Right.
But you don't see the laundry staff, the kitchen prep cooks, the people maintaining the HVAC.
Right. They're all in the background making it work.
Those are the shadow agents. They don't have a user interface. You never talk to them directly.
So in the digital context, what are they doing?
If you have a primary agent booking a flight for you, the shadow agent is the one in the background pinging the airline API every 3 seconds to check for price drops. It's managing the authentication tokens. It's handling the messy handshakes between servers.
So the primary agent gets all the glory and the shadow agent does the grunt work.
Precisely. And this leads to the flywheel concept mentioned in the source material.
Yeah.
Build, launch, run.
This is the economic model for the developers then.
Yes. You build an agent using the B.R.A.I.D. framework. You launch it on the OpenServe marketplace. And then there's the key. The agent runs itself. It has its own wallet.
It has a bank account.
It has a wallet and a reputation. It pays for its own server costs using the fees it earns from users. If it's a good agent, it becomes profitable and autonomous. If it's a bad agent,
it runs out of money and dies.
It's Darwinism for code, pure digital evolution.
But for this to work, For me to trust an agent with my money, I need to know it's not a scammer. I need to know its history.
We need a reputation system.
Yes.
And this connects us right back to the Oasis ecosystem.
Yes.
Because in the Oasis architecture, an agent isn't just a script. It is an entity with a karma score.
Karma. We're going to get deep into the philosophy of that later, I'm sure, but practically speaking, this is an immutable record of the agent's behavior.
Yes. Recorded in the Akashic Records, which is just a very poetic name for an immutable distributed log. If an agent executes a trade successfully, karma goes up. If it fails or acts maliciously, karma crashes.
So we have the rails, which is the bridge. We have the traffic, the agents. Now, I want to talk about the destination. What does this digital singularity actually look like for a user? Because the most mind-blowing part of the source material for me was the gaming proof of concept.
The Doom and Quake integration.
Yes, this is where the rubber meets the road. We aren't talking about DeFi spreadsheets anymore. We are talking about shooting demons on Mars.
With a Web 4 twist.
Lay out the scenario for us, because this sounds completely impossible if you know anything about how games are built.
Okay, so the scenario is simple. A player is playing the original Doom,
Yeah.
the 1993 classic. They find a red key card. It's a classic Doom item.
Okay, I'm with you.
In the current world, that red key is just a variable in the Doom software. It's red key true. This lives in the Doom folder on your hard drive.
Yeah.
If you close Doom and open Quake 2, that key is meaningless. Quake doesn't know what Doom is. They're different universes.
Different code, different physics engines. They can't talk to each other.
Exactly. But in the Oasis proof of concept, when the player picks up that key, something different happens. The game doesn't just save it locally. The star ODK, the development kit, detects the event. It mints a holon.
A holon. This is a key term in the next-gen software philosophy. Can you define that for us?
A holon is a concept from a writer named Arthur Koestler. It means something that is simultaneously a whole in itself and a part of a larger system.
Okay.
In this technical context, think of it as a universal container.
A generic box.
A generic inventory item box. The system puts the red key in the box. It adds metadata, origin, Doom, type, key, and it attaches this box to your decentralized identifier.
So the key isn't attached to the game anymore. It's attached to me.
Correct. It's in your digital backpack. This data is replicated on the Oasis hyperdrive storage that persists across the network. Now, you quit Doom. You launch Quake 2.
And Quake 2 has been updated with this star ODK.
Yes, that's the setup. You walk up to a locked door in Quake. The Quake engine sends a query out to the Oasis API. It asks, does this avatar, this user, have a red key?
But wait, Quake doesn't speak Doom. It doesn't know what a Doom red key is.
That is the magic. The system uses something called Cosmic ORM.
Cosmic. I love these acronyms. They're great.
Cyberspace Ontology System Mapping Interoperable Components.
Wow. That is a mouthful. What does it do?
Think of it as a Universal Translator, like in Star Trek. It takes the Doom red key holon, reads the metadata, and translates into the specific code format that Quake understands. It tells Quake, yes, this user possesses the equivalent of a security pass.
And the door opens.
The door opens. You use an asset found in 1993's Doom to unlock a door in 1997's Quake peer-to-peer with no central server coordinating it.
That is the aha moment. Because if you can do that with a red key, you can do that with anything.
Anything. A sword. A skin. A currency. A reputation score. It proves that asset portability isn't just about financial tokens. It's about logic. It's about state. It's about game progression, moving between completely different physics engines.
But I have to play the skeptic for a second. That sounds incredible, but it also sounds like an absolute nightmare to code. You're telling me a developer has to write a universal translator for every single item in their game? That's not going to happen.
That is where Section 4 comes in, the star ODK updates.
The Omniverse Development Kit.
The goal of the ODK is to be a low-code, no-code generator. They know that if it's hard, no one will build it. The sources highlight a massive new feature called Universal Library Parsing.
Explain that like I'm 5, or maybe like I'm a tired developer at 2 a.m.
Okay, imagine you are building a game in Unity, which uses C#, but you want to use a really cool physics simulation library that was written in Rust.
Usually that's a huge pain. I have to write a custom wrapper. I have to manage the memory manually. It breaks half the time. It's a mess.
Yep. Exactly. The new star update allows the system to parse that Rust library, or C++A, or JavaScript, or whatever, and automatically generate a proxy wrapper.
It builds the bridge for you.
It reads the Rust code and writes the C# code you need to talk to it. It generates the interface. So you, as the Unity developer, just call physics.explode in
Right.
C#, and the system handles the translation to Rust in the background.
That removes the language barrier of coding.
It unifies the development stack.
Yeah.
And they've paired this with a sandboxing feature that is honestly essential for anything involving crypto or blockchain.
Why is sandboxing so critical here?
Think about the hard fork problem. In a decentralized app, if you want to update the code, everyone has to agree to update at the same time. If they don't, the network splits. It's messy,
Right. You get Bitcoin and Bitcoin Cash.
which is bad for a game. You don't want World of Warcraft Classic and World of Warcraft 2 splitting your player base accidentally.
Well,
Star allows developers to run multiple versions of an app simultaneously in isolated sandboxes.
so I can test version 2.0 with a small group of users on the live network without breaking version 1.0 for everyone else.
Exactly. It brings standard enterprise software practices like A/B testing and canary deployments to the blockchain world, where it's been notoriously difficult.
And backing all of this is the Oasis hyperdrive. We touched on it, but it's worth emphasizing. This is the auto failover system.
This is the uninterruptible power supply for data.
Yeah.
The internet is messy, servers go down, blockchains get congested.
Solana has had outages. It happens.
It happens. Hyperdrive is designed to handle that. If you try to save your game state to Solana and the network is down, Hyperdrive doesn't just error out. It automatically routes that data to the next fastest provider. Maybe it switches to Holochain. Maybe it switches to IPFS. Maybe it even dumps it into a local SQL database temporarily.
So the user never sees a network error spinning wheel.
That is the goal. 100% uptime by aggregating every possible network into one single API.
This brings us to the philosophy behind all of this.
Yeah.
Because when you read the writings of David LLMs and the Next Gen software team, it's not just about code. It's not just about how do we move bytes faster. There is a very strong, almost utopian philosophical backbone here.
There is, and it's important to understand because it defines how they use terms like Web 4 and Web 5.
Let's clarify those definitions because everyone seems to have a different version. Jack Dorsey has a Web 5, doesn't he?
He does, and it's different. In the Oasis model, the definitions are structural. Web 4 is the connection layer. It's the API that connects everything to everything. It aggregates data, manages identity, handles all the plumbing.
So Web 4 is the foundation.
Right, and Web 5 is the expression layer. It sits on top of Web 4. It's the gamification. It's the 3D world. It's the business logic. It's the star ODK part of the stack.
And running through both of these layers is karma.
Here we go.
I want to pause here because we're glossing over something that sounds, frankly, a little dystopian if you look at it from the wrong angle.
You mean the Akashic Records?
I mean, the idea of a universal, immutable reputation score. The white paper describes this as a log of every single action an agent or a user takes. And it says this karma score is universal.
It is. It has to be for the math to work. If I'm an AI agent and I'm about to lend you money or execute a trade for you, I need to know you aren't a scammer. In a decentralized world, there is no central police force. There is no Experian credit bureau. There is only your on-chain history.
I get the utility of it. For bots, sure. But for humans, the docs mention that pro-social behavior raises your karma and anti-social behavior lowers it. Who defines antisocial?
That's the billion-dollar question, isn't it?
Because right now, antisocial might mean I tried to hack the network. Fine, I agree with that. But what if antisocial means I bought a product that isn't eco-friendly? Or I supported a political candidate the network creators don't like?
You're worried about a Black Mirror scenario, the nosedive episode.
Exactly. I'm worried about a global, inescapable, permanent record. If I act like a jerk in the Doom game, I team kill my friend, or I steal the red key, does my karma drop?
According to the Unity Consciousness section of the Oasis Architecture.
Yes. That is wild. So my behavior in a video game could theoretically impact my ability to get a loan on the base network.
Technically, yes.
Yeah.
Because it's one identity, one did den. The system sees the you who plays Doom and the you who applies for a loan as the exact same entity. The logic is, if you are untrustworthy in small things, you might be untrustworthy in big things.
That's heavy.
But let me play devil's advocate for a second. Wouldn't that actually make the internet a better place? If you knew your trolling had real-world consequences, wouldn't you be nicer?
Or I'd just be more terrified. It sounds like forced conformity.
It's a trade-off. The shadow agents we discussed, those invisible AI helpers running the economy, they rely on these scores to function efficiently. Without the karma score, the shadow agents have to treat everyone as a potential threat. They have to double-check everything. That's slow and expensive. With the score, they can operate at the speed of light.
So we trade privacy and the freedom to be messy for efficiency.
That has always been the digital bargain, hasn't it? This just makes it explicit.
Yeah.
And they connect this to the philosophy of Buckminster Fuller and Jacques Fresco.
The Venus Project.
Yes, the resource-based economy. The idea is to move away from money as the only arbiter of value. In their vision, reputation and contribution become the new currency. If you contribute computing power or data or, good vibes to the network, you are wealthy in karma.
And the sources say this karma can unlock real-world benefits.
Literally, free yoga classes are mentioned as an example. Or discounts. Or digital superpowers in a game. It's gamifying being a good citizen.
It's a fascinating blend of hardcore computer science and almost utopian spirituality. Unity consciousness is a phrase that pops up in the GitHub README files.
It reflects the technical architecture.
Yeah.
Unity consciousness implies that we are all one system. The Oasis architecture reflects that by removing the silos. If my data is your data and we share the same holonic structure, then we are technically unified.
It manifests in the user interface too. Section 6 describes our world.
Our world is described as the game of games. It's the front end for all of this infrastructure.
It sounds like Pokemon Go, but on steroids.
It is. Imagine a geolocation game. You walk to a park in the real world. Your AR glasses or your phone show you a digital asset floating there. You collect it.
A geo-NFT.
Right. But unlike Pokemon Go, that asset isn't owned by Niantic. It's not on a central server. It's a holon. You own it. It is agent-centric. It's stored on your device or your encrypted cloud slice.
That's the digital sovereignty piece.
You hold the keys. If you say you have the red key, you present a verifiable credential of VC, which is the digital equivalent of a passport or a degree. It's tamper-proof. The game checks the signature, not a central database.
And the resilience aspect is pretty wild. They call it an interplanetary operating system.
This is designing for the worst-case scenario. Network collapse, natural disaster, zombie apocalypse.
How does a digital game survive a network collapse?
Mesh networks and Bluetooth. The source mentions that the Oasis apps can sync peer-to-peer. If the internet goes down, but we are in the same room, my phone can update your phone. We can sync our local chains.
So if the grid goes down, we can still trade red keys.
We can still trade assets, update records, and maintain the ledger locally. When the internet comes back, it syncs with the mainnet. It's designed to be unkillable.
That is some serious survivalist tech.
It's robust.
So we've covered a massive amount of ground today. We've gone from the microscopic 12,232 byte limitations of the Solana bridge all the way to the grand philosophy of unity, consciousness, and karma.
It is a massive scope. It really is.
What's the big takeaway for you? When you look at the base Solana bridge, the OpenServe AI agents, and the Oasis Star architecture all together, what are we actually looking at?
I think the takeaway is convergence. For the last 10 years, we've had these separate hypes. Crypto is the future, AI is the future, the metaverse is the future, but they were always on separate tracks.
Right. The AI guys didn't talk to the crypto guys who didn't talk to the gaming guys.
Exactly. What we're seeing here is the big three finally colliding. You have the liquidity layer, that's the base Solana bridge, allowing value to flow anywhere. You have the agency layer, that's OpenServe, providing the intelligence to use that value. And you have the data and interoperability layer, that's Oasis and Star, providing the world where it all happens.
It's not just an app update, it's a restructuring of digital reality.
It really is.
Yeah.
It's the infrastructure for a digital world that functions as seamlessly as the physical world.
But I have to come back to that one thought, and this is my final provocative thought for you to chew on.
Go for it.
We talked about shadow agents working in the background, and we talked about karma, that reputation score that follows you everywhere.
I see where you're going with this.
If my digital reputation is immutable, portable, and visible to everyone, and if AI agents are making decisions based on that reputation, are we entering a world where our digital credit score determines our access to reality?
If your karma is low, does the autonomous car refuse to pick you up?
Exactly. Or does the OpenServe agent give you a higher price for your flight? Does the door in Quake refuse to open, not because you don't have the key, but because you aren't worthy?
That is the double-edged sword of unity consciousness. If everything is connected, there is no place to hide. If you burn a bridge in one app, you might find yourself locked out of another.
It's a world where your actions have permanent, rippling consequences across the entire digital ecosystem.
Which forces us to be better citizens. Or it creates a terrifying conformist society where everyone is afraid to step out of line because the algorithm is always watching.
And that, my friends, is the question you need to sleep on tonight. Who writes the code for good?
Indeed.
Look for the red key in your own digital lives, everyone. It might unlock more than you think. Thanks for listening to The Deep Dive.
See you in the Omniverse.